Hey there, everybody. Today I'm sharing a brand new assignment for this week. It's called Catapult Quadratic Formula. I know we've been working on our catapults for a couple weeks now, and now it's time to put that math to work and actually calculate the quadratic formula for it. This is going to be a series of 4 or 5 videos. That way they're not too long for you, and you can kind of click around to what you want. But I'm going to be walking you through how to fill out all of the different steps for this assignment. So there's step 1, where you identify your variables, step 2, step 3, step 4. Again, I'll have a video for each of these steps. Watch those videos in order for you to, really understand what's going on for this assignment. This video is also going to be for step 1. So if you already know how to do step 1, go ahead and skip ahead to the other videos, but here we go. So how to create your own quadratic formula. I'm going to make this into a presentation. And so the very first step is you need to use your data. In order to use your data, you have to have your data. I notice many of you have your roots already identified, but just a reminder for how to find those if you haven't found them already. The roots of your graph are wherever the height is 0. So if the height is 0, I'm going to put on my little laser pointer. So here is where my height is 0, and the beginning part is where my height is 0. So root 1 will be where your catapult is. Now I know at this exact point, our catapult isn't technically at 0, but we're going to use this as 0, and don't worry, it's not going to mess up our data too much. It'll be negligible, and our quadratic formula will still work. The other root, will be where your projectile hits the ground. It's your maximum distance. And that's here where it hit the ground. So at this point, you should have already measured your maximum distance. That's the farthest that your projectile can launch. Now be careful when you're measuring this. It has to be where it first hits the ground, not where it rolls to. Again, root number 2 is your maximum distance, which is where it first hits the ground. Moving on. Finding your maximum height coordinates. At this point, you should have already measured your maximum height. If you haven't done this, go back and do it. Sometimes it helps to put a ruler on the wall or to have someone stand like to the side of your catapult so they can pinpoint where that maximum height was and then measure it afterwards. But your maximum height is going to be where your vertex is. So it's this middle top part here. That's the maximum height that it reached. Once you have your maximum height, you can figure out the coordinates. The y-coordinate is that actual maximum height. Whatever you measured, boom, you can use that. That's your maximum height. That's your y-coordinate that you're going to use for your vertex. The x-coordinate is the horizontal distance from the catapult when the maximum height is reached. So it's this distance down at the bottom, that blue line, that is your x-coordinate. So when you find your vertex, your maximum height, that's your y-coordinate. And then the distance from your catapult, that's your x-coordinate. Your y-coordinate is pretty straightforward. Again, maximum height. And then your x is going to be half the distance. So I know that this isn't, again, perfect. If you look at this graph, right, we have our maximum height. You already measured that. Now this isn't a perfect half of the whole distance of your projectile motion. Now that's not going to get in the way here, so don't worry about that. When it comes time to making your vertex coordinates, your x is going to be half your maximum distance. It won't be perfect, but it won't throw your data off enough in order to throw off your final numbers. So the units, this is a big piece. I was looking at some of your units. You really want to make sure they're consistent. For instance, if I'm measuring my distance to my maximum height is 3.2 meters and my height is 5.2 meters, that works because I'm measuring both of them in meters. 14.5 inches and 6 inches, that works. That means I've got 14.5 inches to my center, and then I've got 6 inches to my maximum. Obviously, this data is not for this graph, but as long as the unit's the same, you're good to go. Now, what I've seen a few of you do is that you've measured in feet and inches. That is a no-go. It has to be in the same units. So what you can do in this case is you can take your inches and convert them to feet, or you can take your feet and convert them to inches. If you have a hard time figuring out how to do those conversions, text me, email me, comment, whatever. I will help you figure that out. But it is key that you have the same unit for all of these. So step 1 is identify your known variables so you can tell how to get these numbers, basically. So your maximum distance tells your roots. We just went over this, but I want to make sure you understand. So the distances where your heights are 0, those are your roots. So root 1 is going to be 0. It's going to be that starting point over here. Whoop, whoop, whoop. And then root 2 is your maximum distance. That's this pink star here. That is the maximum distance that your projectile was launched while in the air. Your maximum height tells you your vertex. Now your vertex is going to have an x-coordinate and a y-coordinate. Your y-coordinate is your maximum height. You can see our vertex is this yellow star. And the x-coordinate is going to be half of your maximum distance. So whatever distance you have for root 2, you're just going to cut that in half, and that will turn into your x-coordinate. Yeah. So what will this look like with your actual data? If root 1 is 0, root 1 is actually going to be 0 for all of you. It's going to be at that starting location where that purple star is. Root 2 in this particular graph is 1.6 meters. So that is where my projectile hit the ground from the starting location. That's the maximum distance is root 2. And so I have a number for it. My vertex was 0.8 meters out from my starting point and 0.2 meters up. You can see that in the graph. Boom, that's where my star is. So the way I would identify these variables on the assignment is my x is equal to 0.8 meters, because that's how far away it was from the beginning point. And you'll also notice that it's half of my root as well. And then the y is going to be 0.2 meters, because that was the maximum height. And just like that, you've already finished step 1, which is identifying your known variables. If you need to rewatch this video, go for it. If you have questions about this video, please email me and ask. I don't want you to be confused by this. I know it's complex, and I know it's the first time you're doing it, but you can do it. In the next video, we will be doing step number 2 on that assignment that was assigned this week. Thank you very much for watching, everybody, and good luck.